Hi, so today I'm talking about the transformation of pyruvate, which we created in glycolysis, to acetyl-CoA and how that's going to be used within TCA, the citric acid cycle. So for this reaction, what we have is essentially the pyruvate from the glycolysis, and the whole reaction itself is going to be catalyzed by pyruvate dehydrogenase complex, which is actually made up of 3 different enzymes. So the first one, E1, we have pyruvate dehydrogenase, E2, dihydrolipoyl transacetylase, and then E3, dihydrolipoyl dehydrogenase. So this complex is going to catalyze all of these steps. The first step, we're going to take the pyruvate that we made in the glycolysis, and we're going to have a coenzyme TPP. Anytime we have a coenzyme in a reaction, we're going to have to regenerate it in later steps. So that's just kind of something to note right now. So the pyruvate, we have these the CO2, and what we're going to have is the TPP is going to attach to the enzyme pyruvate dehydrogenase, the E1, and it's going to catalyze that first step in the reaction. It's going to remove this CO2, and we're going to have CO2 as a product of that reaction, as well as hydroxyethyl TPP complex. Now, if we take that and we go into step 2, we have that hydroxyethyl TPP complex, and we're going to have it here in its oxidized form. So it's going to be a reducing agent to this other coenzyme, lipoamide. So again, coenzyme, we're also going to have to regenerate that, still have to regenerate the TPP. So this reaction is catalyzed by pyruvate dehydrogenase, and it's a oxidative reducing reaction. We're going to have the oxidized TPP complex, and we're going to come over here and we're going to have just TPP regenerated, and then we're going to have acetyl lipoamide, and it's going to have that acetyl group that we're actually going to use in the next step. Step 3, we have coenzyme A and the acetyl lipoamide that we just produced. It's reaction catalyzed by dihydrolipoyl transacetylase, and what we're going to create is acetyl-CoA, and acetyl-CoA is what in the next TCA mechanism is what's going to be used primarily by TCA. And then we're also going to produce dihydrolipoamide. And then from here, we're going to be able to go into step 4, where the dihydrolipoamide, we're going to take the hydrogens off, and we're going to, we are going to produce FADH2, which we know is then going to produce into NADH. Since we had 2 pyruvates at the beginning of this, we're going to produce 2 NADHs, each of which is worth 2.5 ATP each. So in this step, we're going to be using FAD. It's used in its oxidative form to kind of transfer those electrons, and we're going to transfer them to the FADH, and then the bond between these 2 sulfides is going to reform, and we're going to regenerate the last coenzyme lipoamide. And that's how pyruvate to acetyl-CoA occurs, and then the energy and the ATP that this reaction produces to continue on into the TCA cycle using this acetyl-CoA.